Hey everyone, in this video I want to give an introduction to graphs and how they work. So as you can see, I have grid lines here to help me draw a graph. So let's talk about what a graph is. Let's start drawing one by connecting two lines. So we have one line going from top to bottom. We will draw it like that. And just keep in mind that lines extend forever. So you see these arrows over here that goes up. So this line goes all the way up in this direction, all the way to infinity. It doesn't stop. And same thing with this arrow. This line extends all the way down to infinity. So we have this line that goes from top to bottom. Perfect. Let's just put that arrow back. And we have another line that goes from left to right to infinity in both directions. So let's draw this line from left to right. Excellent. So this line that goes from top to bottom, this is called the y-axis. So this is called the y-axis. And this line that goes from left to right, this is called the x-axis. So I'll write it here, x-axis. In fact, I'll move that. I'll move that word over here. That's the x-axis. So y-axis and x-axis. So the y-axis and x-axis make up a graph. And you can see this graph has four sections. It has this section over here, over here, over here, and over here. It has four sections. Or to be more precise, it has four quadrants. So these are all called quadrants. So let me write that down. Quadrants. Quadrant. So the quadrant that's over here, this is quadrant 1. So quadrant 1. The quadrant over here is quadrant 2. This is quadrant 3. And this is quadrant 4, right here. So there are four quadrants, 1, 2, 3, and 4. And one more thing, where the x-axis and the y-axis meet, right here, this is called the origin. So I'll write that over here, origin. Perfect. So this is a graph, and that's what this is how a graph is composed. So, okay, what can we do with the graph exactly? Well, we can plot points on it. So before I do that, let me go ahead and mark some numbers. So first on this x-axis, right here at this origin, that is going to be 0. I'll just write a 0 maybe right here. And then I'll keep going. So this will be 1. This spot right here, that'll be 2, 3, 4, 5, and so on to infinity. We already have 0 in the middle. Now let's go in the other direction. So we have -1 here, -2, -3, -4, -5, and so on to negative infinity in the other direction. So it's sort of like a number line on the x-axis. And we'll do the same thing for the y-axis as well. So we'll go up. So up is the positive numbers. So up here is 1. Up here is 2, 3, 4. And so on to infinity. It goes all the way up. And right here, we'll go to the negative numbers downwards. So this is -1. That's -2, -3. And we can just extend this a little bit more. Let me put that back. A little bit more down here. -4. We can also write -5, and so on all the way down to negative infinity. Okay, so we filled out our graph, we've labeled everything. Now let's go ahead and plot some points on this graph. So let's say we have a point right here. we have this point. So this point, if you follow the x-axis, it's 1, 2, 3, 4 from the x-axis, and then it lies on 2 on the y-axis. So shown another way, if you take this point and then draw a dotted line all the way down, on the x-axis, it touches 4, and then if you draw a dotted line all the way to the y-axis, it touches 2. So we can display this point, or we can represent this point as an ordered pair. So let's set up a parentheses, and all points can be represented as an ordered pair. So let me write that down, ordered pair. Ordered pair. And all ordered pairs can be represented as x comma y. So x comma y. So what is the x in here? The x in here is what number does this point touch? Does the dotted line touch on the x-axis? That's 4. So that's 4. Let's write 4 for the x. And now what is the y? So what point does this dotted line touch on the y-axis? That is this 2 right here. So for the y, let's write 2. Therefore, this point right here, it can be represented as 4, 2. So 4, 2. That is how we represent it using an ordered pair. So let's plot a few more points just to get used to it. Let's say we had another point right here. So we have it in quadrant 4. And how do we represent this as an ordered pair? Well, we'll use the same method. Let's draw a dotted line, first all the way to the x-axis. If you draw it all the way there, you'll hit the number 2 on the x-axis. And let's draw another dotted line all the way to the y-axis. And if you do that, you'll hit the number -3. So our ordered pair are x comma y. Our x comma y, so what is our x? Well, what does it touch on the x-axis? It touches this 2 right here. It touches this 2. So our x is 2. And what is our y? So over here on the y-axis, it touches this -3. So our y is -3. Therefore, we can represent this point as 2, -3. 2, -3. We'll do one more example. Let's say we had a point over here. So again, we can use the same method. Let's draw a dotted line all the way to the x-axis and another dotted line all the way to the y-axis. So we can represent this as x comma y. And what is x? So what number does it touch on the x-axis? It's this -3. So our x is -3. So let me make that a little bit bigger, and let me just move this 3 just a little bit this way. So let's write down our ordered pair. Our x is -3, and what's our y? So following this dotted line, our y is also -3. Perfect. And you might notice something. In quadrant 1, so going back to quadrant 1, this point right here, the blue, both the x and y are positive. And in quadrant 4, the x is positive and the y is negative. In quadrant 3, both the x and y are negative. And in quadrant 2, let's actually plot a point real quick. Let's say we had a point right here. So you can use the same method. On the x-axis, it touches -1. And on the y-axis, it touches +3. So we can write this as an ordered pair, -1, +3. And anything in quadrant 2 will have a -x and a +y. So anything in quadrant 1 in an ordered pair, both are positive. In quadrant 2, it goes negative x and a positive y. And in quadrant 3 down here, both are negative. And in quadrant 4, you have a positive x and a negative y. So that is how we plot points, and that is how you represent them as an ordered pair on a graph. So now that we got that out of the way, let's erase some of this. And let's try plotting an equation. So let's erase all this. Okay, here we go. Okay, so let's try plotting an equation. So let's say we had this equation, for example. Let's say we had y equals 3x plus 1. Okay, y equals 3x plus 1. So before we get to plotting it, let's actually take a look at this equation. So as you can see, we have two variables. We have an x and we have a y. So these two variables in relation to this graph, the x represents the x-coordinate and the y will represent the y-coordinate. So how does plotting this work exactly? Let's go through an example. So let's make a table. Let's put x in this table and y as the header of both of these columns. And for x, let's just use a few example numbers. Let's say -1, 0, and 1. We just chose these numbers arbitrarily. No reason. We just want to see what y will be. So we want to see what y will be when x are these values. So when x is -1, when x is 0, and when x is 1. Okay, so if x is -1, so this first one right here, then what is y exactly? Well, what we can do, we can get back to this equation right here, and we can substitute the x for -1. So let's rewrite this. So let's erase some of this. Y equals 3. So instead of times x, it's times -1 plus 1. Let's go ahead and evaluate this. What is 3 times -1? That is -3. Then plus 1. What's -3 plus 1? That is -2. Good, so y equals -2. So let's put a -2 right here corresponding to this -1. So when x is, so what this means, or how this is supposed to be read, is when x is -1, y is -2. So let's try it for 0. So let's erase this. And instead of substituting for -1 for x, we'll substitute for 0. So we'll substitute as 0. So what is 3 times 0? 3 times 0 is 0. So 0 plus 1 is just 1. So when x is 0, y is 1. Now let's try it again for when x equals 1 right here. So what is y when x equals 1? Let's give it a try. So instead of substituting 0, we're going to substitute a 1 for x. So let's try it. 3 times 1 is 3. And then plus 1. What is 3 plus 1? That is 4. So when x is 1, y is 4. Good. So now that we have this table with x values and y values, let's represent all of these as ordered pairs. So let's represent all of them as ordered pairs. So x comma y is how you represent an ordered pair. So what's x in this case? This is -1. So -1 comma -2. Good. And let's do this next one. This is 0 comma 1. And this next one right here, it's 1 comma 4. X comma y, 1 comma 4. And let's go ahead and plot these points. So first, let's plot the -1 comma -2. How do we do that? So what we're going to do is we know the -1 is the x value. So first we move left and right. So we start at the origin, and we're going to move either left or right. So which way do we go, left or right? Well, -1 is this way, to the left side. And we're going to move one space to this -1 over here. So far we're here. And our y value says -2. So -2 is down there. So we have to move down there to -2, where it meets -2 on the y-axis. So this point will be -1, -2. So that's our first plot. That's our first point that we plot. -1, -2 is right there. Now let's plot 0, 1. So 0, 1. So 0 is the x. So we don't move at all because we're already at 0. And now y, we're going to go up by 1. So we're going to go up to 1. So right here is 0, 1 at this point. And what's our next one? 1, 4. So 1, 4, what we're going to do, our x is 1. So we start at the origin, we start at 0, and we're going to go to the 1. So we're here, and now we're going to go up 4. So 1, 2, 3, 4, right here. Let me just erase these. So this point that we plot right here is 1, 4. So we plotted the points, and for this equation, y equals 3x plus 1. Now let's connect them. Let me just make them a different color so it's easier to see. So we plotted this point, we plotted that point, we plotted that point, and we plotted that point. Excuse me. Plotted that point, and that point as well. Good. So now let's connect these points carefully in a straight line. So let's go ahead and connect this point to that point, and we'll connect this point 0, 1 to the point above 1, 4. And let's go ahead and extend this as a line with arrows coming out of either end. And there we go. We've successfully plotted the equation y equals 3x plus 1. And this is the line that it forms. So that is how you plot an equation. And there's one more thing too. We're going to learn about the x-intercept. So the x-intercept and the y-intercept, let me make that a different color. One second, x-intercept. And then y-intercept. Y-intercept. So what is the x-intercept? Let's start with that. The x-intercept is what is the value of x when y equals 0. So let's look for the x-intercept of this equation we drew right here, y equals 3x plus 1. So when y equals 0, what does x equal? So as you can see right here, y equals 0 at this point right here. So y equals 1 at this point, y equals 1 over here, but y equals 0 right here. So at the origin. And what basically on the x-axis, what point does the equation in blue touch on the x-axis? It touches this point right here. And what is that point exactly? It's a little hard to see, but it's a number between 0 and -1. But there's a way to find this out algebraically. So what you would do, let's scroll down a little bit. If we wanted to find the x-intercept, so the x-intercept of, what was the equation? Y equals 3x plus 1. So y equals 3x plus 1. So what we do to find the x-intercept, we set y equal to 0. So instead of y, we will substitute that for 0. So 0 equals 3x plus 1. And then we're going to solve for x. 3x plus 1. We'll solve for x. So let's go ahead and solve for x. So we have to isolate it. So let's subtract 1 on both sides. So 0 minus 1, that's negative 1, equals 3x, since those cancel out. And let's divide by 3 on both sides. So x equals negative 1 over 3, so negative 1/3. So negative 1/3 is the point that this equation touches on the x-axis right here. So that is the x-intercept. So the x-intercept is represented as an ordered pair. So the x-intercept right here, it is negative 1/3, comma 0. So in any x-intercept, the y in the ordered pair is always 0, because the x-intercept is simply what does x equal when y is 0. And it goes the other way too. The y-intercept is what does y equal when x is 0. So the y-intercept, let's write that over here, and let's try solving it algebraically. So the y-intercept, we have to set x to 0, x equal to 0. So let's write the same equation as before, y equals 3x plus 1. And we are going to set x equal to 0. So let's go ahead and do that. Y equals 3 times 0 plus 1. So what is 3 times 0? That is 0. So we're just left with y equals 1. So we have y equals 1. And how we represent this as an ordered pair, this would just be 0, comma 1. Because y is the 1. So that's y, the second number in the ordered pair. And the first number is x, which we set to 0. So 0, comma 1. And you could see this on our graph as well. 0, comma 1, so 0, comma 1 is over here, 0, comma 1. This is where the blue equation, y equals 3x plus 1, this is where it touches the y-axis at this point right here, 0, comma 1. So that's how you find the y-intercept of an equation. So I hope this video helps, and please let me know if you have any questions down in the comments below, and thank you for watching.